Separable differential equations. Okay, so what we're going to be doing is we're going to be separating variables in a differential equation. So in order to be a differential equation, it just has to have a derivative and an equal sign. So this right here is a differential equation. It has a derivative and an equal sign. Okay, so what we're going to do is separate the variables so that we can integrate and solve. So what are we solving for? So anytime we've got a differential equation like this, we're looking to find y. What is the function so that when we take the derivative of it, it gives us this. And notice there'll always be x's and y's inside. So again, remember here's an example too. So here's a differential equation, has a derivative and equal sign, x's and y's in lots of different places. So lots of times there's going to be just two terms. So one term, two terms, right? Oops, sorry, one term, two terms. And so the first step will always be to rewrite y prime as dy over dx. That's a big deal. Don't put dx over dy. So y prime is dy over dx. Sometimes you'll have y prime equaling dy over dt if you have t's as your independent variable. So when you see x's, you put dy over dx. All right. So now we're going to get the y's on one side, the x's on the other. So starting with this, so here I have dy over dx, so I multiply both sides by dx, right? And then I'm going to multiply both sides by 4y cubed. So I get this is this. So look at that. It's ready for integral, right? You just need an integral sign. So we put the integral down on both sides. And then we take the antiderivative, right? So take the antiderivative here, we get this, plus the constant. Take the antiderivative here, La Jolla theorem, we get this, plus the constant. Okay, we're going to always gather the constants to one side, and since I know I want to solve for y, I'm always going to put the constants on the side with the x's. So you could just skip this d and e step, just take the antiderivative, so go right from here to here. Say y to the fourth. Don't put a constant on this side. Get the La Jolla theorem, 1/2 e to the 2x, and gather your constant, one constant on the side with the x's. Okay, so then we need to finish solving for y, because that's what the solve means, is solve for the y. So I'm going to take the fourth root, and since it's fourth root, I have to put plus minus, right? If it's square root, fourth root. If it's a even root, you got the plus minus. Then you add, notice that you take the root and the c is on the inside of the root, right? So be careful. So what would be wrong would be to say y is equal to the fourth root of 1/2 e to the 2x and then put the c on the outside. So that's wrong, right? So don't do that. Okay. Yes, so you always want to make sure you leave dy and dx in the numerator, right? So here, when you start off rewriting y prime as dy over dx, always cross multiply so you get the dy's and the dx's in the numerator, because you can't take the integral of dy or dx in the denominator, right? Okay, so let's look at another one. So 2y prime is equal to this. Okay, so start by rewriting y prime as dy over dx. Don't get that mixed up. If you get that mixed up, you'll be, lost in the very first step. It's dy over dx. So then I'm going to multiply by dx and multiply by ln of y. And then I'm ready for integral signs. So I put the integral signs in. And so this is why I've had you practicing integrals, because you have to know, you have to recognize and say, oh no, what do I do here? Oh, this will be an easy u substitution, right? U equal, oops, I meant ln of y, right? U equal ln of y, du is 1 over y dy. And so then I get integral of u du on this side. This side I can take the integral, and I know I want to put the plus c on this side. So I take the antiderivative, so u squared over 2, the 2 here cancels, so I get to here. And so then I put the y's back in, and now remember you have to do the algebra to solve for the y. So that means I'm going to be taking the square root of both sides, right? So square root again, put the plus minus, square root, x squared over 2 plus c, and then I have to solve for y. So how do you undo an ln? You take the e of both sides. So e to the ln of y gives me y, and I have e to all of this. So all of this is up in the exponent of the e. So be really careful about where that c is, right? So let me show you something that would be wrong. So if you had at this point here done this and forgot to put the plus c, so again, this is incorrect. If you forgot to put the plus c and you said, okay, now I'm going to put the y's back in, now I'm going to solve for y, and then you go and take the square root and you get to here and you say, oh yeah, plus c, tack it on at the end. Do you see how very different the answers are? So this one is correct. This one is incorrect. So be really careful with the c.